One of the issues that exists in environmental science is, believe it or not, comes down to word use and marketing and how we present things to the general public and to the world. Now, on that topic, let's talk about renewable energy. So, renewable energy suffers from a word use problem. Back in the day, it was called alternative energy, and then it became the concept of renewables, and it was sold as this idea that it would renew itself forever, constantly self-perpetuating, that it was not just renewable, but sustainable, everlasting, the future of mankind, and completely clean with no drawbacks. Well, that isn't true, okay? There's several parts of that statement that isn't true. And one of the things that I want you to learn in this class, if you learn anything, is that everything is connected. There is a pro and con to everything. There's nothing in environmental science is black and white. Everything is complicated, and there's upsides, downsides, and multiple connections with every single thing in this subject, including renewable energy. It's not the all pros and no cons idea, okay? Let's take a look at a few. Windmills. Okay, so windmills. Steel, grease, aluminum, oil, fiberglass, plastics, wires, generators, paint, all the brakes that have to be maintained, everything else, not to mention all the e-waste, all the computers and things that are in those. Those are not renewable. The wind is renewable. The wind's going to blow again. Wind's always going to be blowing. As long as there's a sun to cause uneven heating and cooling on the earth, there's going to be wind. But that doesn't mean that the windmill is renewable. There isn't just an unending source of popping out 5-6 megawatt windmills left and right. That's not the case. There's tons of things in the windmill that are not renewable. So that begs lots of questions. What are we going to do? How do we recycle it? How do we reuse it, or can you? What do we do with all the computers in them when they're out of date? Does that just become e-waste and just get added to the e-waste problem? I thought it was renewable, right? What about noise pollution? What about the constant low-end whoosh, 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 morning, all day, all night, constant like water torture, the sound of that whoosh, whoosh, whoosh from the windmill? What about the super subsonic low frequencies that mess with your brain and everything else? How far away do you have to be from a windmill for that to not happen? Some research is showing 1,000 meters, a full kilometer away from a wind farm before you're not affected by the noise pollution. A lot of folks don't tell you about that. Hydroelectric dams. An unbelievable amount of concrete and steel goes into a hydroelectric dam. How are you going to reuse that? What do you do with it when it's past its prime? There's a massive startup cost. Most of them cost in the billions of dollars. Windmills are in the millions of dollars. There's environmental impacts there too. There's concrete. There's at least 50 foot of concrete going straight down in the ground that they have to put the windmill on top of. Concrete itself has an environmental impact. It has a CO2 impact. It has an environmental footprint. It has an effect on groundwater and soils and everything else. Just concrete alone. And it would shock you how much concrete is in a modern hydroelectric dam, not to mention the steel. You can recycle steel to some extent, but how are you going to get that out of the hydroelectric dam? You can't just pull the cord, right? It all comes out. There's a colossal change to the ecosystem. The river is changed permanently, right? For the entire life of that dam, that river has changed. All the migration routes are changed, the sedimentation's changed, the entire ecology of that river is now changed. And then when you get a massive lake, there's methane produced in the deep water decomposition under the lake. So people will tell you that there's no carbon footprint with a hydroelectric dam. That's simply not true. There's a carbon footprint in getting that steel out of the ground and getting it shipped. There's a carbon footprint just in the concrete drying. There's a carbon footprint in getting all that concrete there and poured and everything else. Huge amounts of machinery and everything else, diesel that gets used just to create one before you even turn it on. And then there's a carbon footprint from the decomposition at the bottom of the lake. So, is it renewable? Yeah, like gravity is. And that's how hydroelectric dams work, right? It's just gravity running downhill, pulling water downhill. So yeah, gravity's renewable. Is wind renewable? Yeah, wind is. But the dams and the windmills aren't. They have a huge impact. And they have a huge cost. They have a startup cost. They have a maintenance cost, everything else. So and nothing is cut and dried. Nothing's black and white. Everything is connected. Everything has a pro and con. So why would we even bother with renewables? So there's a few things here. Market diversity. Market diversity. Where are we getting electricity in the energy market? Market diversity is always good. That is always a good thing, is to be able to buy from different places. Whether it's you buying, is cities buying, or whomever is the energy consumer, provinces, whomever, is buying the electricity. It's always important to have multiple ways to buy from. If you get pigeonholed into one thing and you have to buy from one or two sources, then corruption and abuse and everything and inefficiency is going to happen. Competition is good. Market diversity is good. It creates more jobs and it creates consumer choice. And anyone, I believe that those things are good. And I think most economists and other teachers will tell you the same. How long will coal, oil, and natural gas last if there is no other option? Significantly less, okay? So if you're a fan of natural gas, if you're a fan of coal, you're a fan of oil, then you need to be a fan of renewable energy sources or alternative energy sources. Because the longer we mix those into the market, the longer those, or the more those are taking a share of the demand, then those non-renewable fossil fuel resources will last longer. So you need to ask yourself, if you're a fan of natural gas, are you a fan of natural gas for 100 years or 200 years? And if the answer is 200 years, then you need to look into also, supporting with your ideas and everything, things like windmills and hydroelectric power, thorium and uranium power, things like that, the other market options. You can't say it's all bad except for this one thing. That's never a good idea. Also, water. This is another thing that is different than any sort of political leaning or anything like that. Stop right here and look up how much water it takes to frack one frack well. Hydraulic fracturing, how you get natural gas, called fracking. Look up how much water it takes to frack one well, one time. And then it's going to use that much water again every time they frack that same well. Then stop and look up how many fracturing wells, hydraulic fracturing wells, fracking wells, there are just in Texas alone. Take a few minutes and do that. Then when you're done, look up how many frack wells there are in just the United States. And then multiply that times the millions and millions of gallons of water it takes to frack one well. Then try to think, if you can think, conceptualize, if that hasn't already knocked your socks off, think about how much water goes into cooling a nuclear power plant. How much water it becomes nuclear waste because it's been exposed to the cooling rods or exposed to the fuel rods. Then think about how much water goes into all the different wet scrubbers that it takes to do clean coal technology. Getting the sulfur out, getting the nitrogen out, getting the mercury out, and everything else. Think about how much water all that takes. Now, stop and look up how much water is actually drinkable, potable water, right? That we can actually use. How much of the water on Earth is fresh? How much of that can we actually use? And then remember that all that water you just looked up about fracking is permanently contaminated. The water that comes from a nuclear power plant, that's contaminated for like 1,000 years. So remember, that's all being lost over those resources. Now, some water is going to get used in the manufacturing processes of a windmill, but it's nothing compared to how much water is being lost, permanently lost, in a hydraulic fracturing job. So you've got to think about something other than just price per kilowatt hour, just how much steel and aluminum goes into it, just the startup cost. That's not the end of the story. Water is a huge part of the story. How much water is being lost permanently over these energy sources. Non-renewables are non-renewable in every way. So what I mean by that is non-renewables Even that, we should probably change the term of renewables. Non-renewables, that term fits. They are full-blown, not renewable. And so at some point, mankind has to solve its energy future. And you can't entirely put all your eggs in a non-renewable basket. It's that simple. It's just purely not sustainable in every way that you can slice that. And the other part, waste. How much of a windmill is completely waste? Some of it may be. Some of it's probably reusable, recyclable. Does that also apply to nuclear waste? What do you do with spent fuel rods? What do you do with radioactive waste that's going to be radioactive for 800 to 1,000 years? There's no reusing that. There's no upgrading that. There's no recycling that. There's only one thing you can do with spent fuel rods, and that's make nuclear weapons. So one part of this equation is full-blown, just total waste. How much of that water is now waste, right? So why bother with renewables? Even though they're not totally renewable, they're not totally sustainable forever and everything else. Is there a dark side? Sure. But there's another part of the equation that you always got to be looking at, because all of these things are connected, right? So maybe windmills don't create the amount of just waste that other, non-renewable sources take. So even if they're not renewable, are they still valuable? Yes, because there's more to the equation than you might typically think about. So here's what I want you to do. People purchase things, people formulate their opinions, often based on marketing campaigns. So here's what I want you to do. Rebrand renewable energy. Rebrand it. So new name, new concept, new pitch to the American public. Renewable energy sources, what do we call it? How do we sell it? How do we now pitch this idea accurately to the people? Because renewable isn't actually an accurate term. So what's the new accurate term? What's the new marketing campaign, the new ad campaign that we're going to use? What are we going to call it? And how are we going to help the public realize that it is valuable, even though it isn't totally renewable?